Going on, guys? In this video we are going to see how to use the method of Lagrange multipliers to determine the maximum and minimum value of a multivariable function. Here we have a multivariable function, also we have a constraint equation. Now using this multivariable function and constraint equation, we can determine the points that account for maximum and minimum. To find that one, we use this equation, that is gradient of f is equal to lambda times gradient of g. So this is basically we find the derivative, partial derivative of this f with respect to x, and we equalize that one to partial derivative of g with respect to x, and we multiply the partial derivative of g with respect to x with lambda, and we do the same thing for y. Okay, so the equation is going to look like this: fx is equal to lambda times g of x, gx. Okay, this means partial derivative of f with respect to x, and this is partial derivative of g with respect to x, and we do the same thing for y. Fy is equal to lambda gy. Okay, now from this one we can create the equation, but before we do that, we have to rearrange this constraint equation to create another function, like g of xy is going to be equivalent to x square plus y square minus 1. Okay, we bring everything to one side and create an equation. So this is our g of xy function, this is our f of xy function. From this one we are going to derive this equation, and fx is going to be the partial derivative of f with respect to x. Here we are going to have 1, and when we do the partial derivative with respect to x, we treat y as a constant, so this is going to become 0. And in the other side we are going to have 2x, and we multiply this one with lambda, and this y and this negative 1 is going to become 0 because these two are constant. Okay, now let's do the partial derivative with respect to y, and if we do the partial derivative of f with respect to y, this is going to become 2, and this x is going to become 0, so we just get 2 right here, and from this one we get 2y, and we multiply this one with lambda, and from here we have two equations, but also we have to use one more equation from this constraint, okay, in order to find out our x and y values. So from this one we can create x square plus y square is equal to 1. In every equation we have two unknown variables. Now we have to bring it into one unknown, otherwise it's very hard to solve, right? Now we can rearrange this equation like lambda is equal to 1 over 2x, and here we can bring this one into lambda is equal to 2 over 2y, and we can simplify this one. This is going to become just 1 over y, and these two are equal to lambda, right? So we can equate these two because lambda is equal to this, lambda is equal to this, therefore these two are equal. So 1 over 2x is equal to 1 over y, therefore y is equal to 2x. Now what I'm going to do is, instead of this in the constraint equation, instead of y, I'm going to plug this 2x. In that way we will bring everything into one unknown variable, so we can solve for x. Okay, so this is going to become x square plus 2x square, that's going to be equal to 1, and from this one we get x square plus 4x square is equal to 1. From this one we get 5x square is equal to 1, therefore x is going to be equal to square root of 1 over 5. Then this is going to become plus or minus 1 over square root of 5. So this is the solution for x. Now we have to find what is the solution for y. To find that one out, we can use this equation. Y is equal to 2 times x. Okay, and we know that x is plus or minus 1 over square root of y. So if we plug that one, plus or minus 1 over square root of 5, we will get plus or minus 2 over square root of 5. Okay, so we are going to have actually four different points, because we have plus or minus, plus or minus. So the points are going to be 1 over root 5 comma 2 over root 5, and here we are going to have negative 1 over root 5, 2 over root 5, and also we are going to have negative 1 over root 5, negative 2 over root 5, and we are also going to have positive 1 over root 5 comma negative 2 over root 5. Now we have four different points. Now our main purpose is to find out the maximum and minimum, and when we plug these points in this main function, we will get some values. From that values we have to see which value give the higher number and which value give the lower number. The higher number is going to be the maximum and the lower number is going to be the minimum. Now let's go ahead and plug and see what we get. Okay, to do that I'm going to get rid of this part. Okay, now let's continue this one here. So f of xy, now let's take this point. Okay, this is going to be 1 over root 5 comma 2 over root 5 is equal to x plus 2y. Instead of x, I plug 1 over root 5 because our x value is 1 over root 5 and y value is 2 over root 5. So this is going to be 1 over root 5 plus 2 times 2 over root 5. From this one we get 4 over root 5 plus 1 over root 5. That's going to give us 5 over root 5. And if I bring the second point, let's bring this one. Negative 1 over root 5, 2 over root 5. And if I plug this one in this equation, this is going to be negative 1 over root 5 plus 2 times 2 over root 5. So 4 over root 5 minus 1 over root 5, that's going to give us 3 over root 5. And let's bring the third point, this one. This is going to be negative 1 over root 5 comma negative 2 over root 5. And if I plug this in this equation, this is going to become negative 1 over root 5 plus 2 times negative 2 over root 5. So here we are going to have negative 4 over root 5 minus 1 over root 5. That's going to make this one negative 5 over root 5. And let's bring the last point, that is this one. This one is going to be 1 over root 5 comma negative 2 over root 5. And if I plug it in this equation, this is going to become 1 over root 5 plus 2 times negative 2 over root 5. Here we are going to have negative 4 over root 5 plus 1 over root 5. That's going to make this one negative 3 over root 5. Now let's compare these points. Here you can see this is our highest point, because if you look at the numerator, this is the highest value, right? 5 is the highest value. So this is going to be our maximum. And here you can see this is the lowest numerator. So this is going to be our minimum. Okay, this is going to be our minimum. And you can also write this one, like if you simplify this one, because you know that 5 is equal to root 5 times root 5. So one of the root 5 cancels, you will get root 5. And here negative 5 is going to be negative root 5, positive root 5 times negative root 5. And root 5 cancels, you will get negative root 5. Okay, so here negative root 5. And this is going to be our final solution. I hope this helps. Thanks for watching.